we're going to go over question 25 on 2021 Cayley contest. So point J, K, and L forms a triangle whose area is less than or equal to 10. Let R be the region formed by all such point L with the R between 0 and 10, which is the x-coordinate of L, and T between 0 and 10 as well, which is the y-coordinate of L. When written as a fraction in lowest terms, the area of R is equal to 300 plus A over 40 minus B for some positive integer A and B, and the problem wants us to find the sum of A and B. Since the question already gave us the exact coordinate of 2 points J and K, therefore using a coordinate system to solve this question would be very helpful. Let this point be the origin, 0, 0, and J would be around here, which is 2, 7, and let K be around here, 5, 3. And we can use the Pythagorean theorem to get the length of JK, which is 7 minus 3 squared plus 2 minus 5 squared square root. And this gives us 5. So next thing we know is that the x-coordinate and the y-coordinate, which is R and T, all has to be within the range of 0 to 10, which means the triangle must be within this square that has a side length of 10. And this point is the furthest point L can be, which is 10, 10. Okay, so next piece of information that we can make use of is that the maximum area of the triangle is 10. And if we treat JK as the base of the triangle, then we can get the maximum height of the triangle. Another piece of information that we can make use of is that the x-coordinate and the y-coordinate of line L has to be within the range of 0 and 10, which means the triangle has to be in this square that has a side length of 10. And this point, 10, 10, is the furthest point L can be. So next thing we want to do is to find the maximum height the triangle can have if we're using JK as a base of the triangle. And if we use the triangle area formula, we can get the maximum height by 10 times 10. 10 is the maximum area of the triangle over 5, which gives us 4. So that means if we draw two lines over here and here, as a distance between this two lines and line JK is 4. As long as point L fall between these two lines, let's say this line is line 1 and this is line 2, then the triangle formed by point LJK would be less or equal to 10. That means the area that we want to calculate is the shaded area over here. However, as you may already notice that this area is not really in a regular shape, therefore we can only calculate it by using the area of the square minus the area of the small triangle over here and the area of the big triangle over here. But the only thing we know for now is that the area of the square is 10 times 10, which gives us 100. But we don't really know the base and height of neither the big or small triangle. One way to find the base and height of the smaller and bigger triangle is to find the equation for L1 and L2 first. And the first thing we can get is the slope of them because they're parallel to line JK. And the slope of line JK is 3 minus 7 over 5 minus 2, which gives us negative 4 over 3. And therefore, the slope for L1 and L2 are also negative 4 over 3. However, we're still lacking the y-intercept of line 1 and line 2. To find that, one way of doing that is to construct a right angle triangle over here. Oh, because the graph is getting a little messy, so I'll use red here instead. So we're going to construct a right angle triangle over here. And this line, we already know that this line is 4. And because this line is perpendicular to line JK, so the slope of this line would be the negative reciprocal of the slope of line JK, which is 3 over 4. That means this right angle triangle, it's a 3, 4, 5 triangle. And because this line is 4, so this line would be 4 over 5 times 3, which is 12 over 5. And this line would be 4 over 5 times 4, which is 16 over 5. And therefore, let's say this point is called M. The coordinate of point M would be 5 plus 16 over 5 and 5 plus 3 plus 12 over 5, which gives us 41 over 5 and 27 over 5. If we plug this set of coordinates into the equation, then we can get 27 over 5 equals to negative 4 over 3 times 41 over 5 plus the y-intercept. And therefore, we can solve the y-intercept, which equals to 49 over 3. Therefore, the equation for line 1 would be y equals to negative 4 over 3 times x plus 49 over 3. And using the same mechanics, we can construct another right angle triangle over here. And then if we do the same thing, we can get the equation for line 2 as well, which is negative 4 over 3x plus 3. And the last step we need to do in order to find the base and height of those triangles is to find the coordinates of these 4 points. So we already know that the x-coordinate of this point is 0. And the y-coordinate for this point is 0. And the x-coordinate for this point is 10. And the x-coordinate for this point would be... No, the y-coordinate for this point would be 10. And if we plug in those numbers into the equation of line 1 and line 2, then we can get 0, 3, 9 over 4, 0, 10, 3, and 19 over 4, 10. So now we can just do some basic calculation to get the distance here and the distance here to get the area of the smaller triangle, which equals to 9 over 4 minus 0 times 3 times 1/2. And the area of the bigger triangle would be 10 minus 19 over 4 times 10 minus 3 times 1/2, which gives us 100 minus 3.375 minus 18.375, which is 78.25. And if we convert this back into a fraction form, we can get 313 over 4. Therefore, so A would be 313 minus 300, which is 13, and B would be 14 minus 4. 14 minus 4, which is 36. And the sum of AB would be 13 plus 36, which is 49. And the answer is D.